Let's discuss the solution for questions from formative exercise 5.2. Question number 1. A fair coin is tossed 4 times. Construct a probability distribution table of getting the tails. Okay. Let's take x as number of x number of times getting the tails. So x can be written as 0, 1, 2, 3 and 4. Okay, and we're going to find the probability for each of these value of x. Okay, so let's build a table first. Okay, so here I'm going to write the values of x: 0, 1, 2, 3 and 4. And then in the second column we're going to calculate the probability for each of this value of x. Okay. So let's start with for C0. Okay, and the probability of getting a tail is actually 1/2, and the probability of not getting a tail is also 1/2. So 1/2 to power of 0 multiply with 1/2 power of 4 minus 0, which is equals to 4. Okay, and then I'm going to use the calculator to find the value of this. So for C0 multiply with 1/2 power of so I think I better change this to for C. I'm going to put a x because we're going to use this formula number of times. So times 1/2 power of x multiply with 1/2 power of 4 minus x. So the first value of x is equals to 0. 0. The value is 1/16. 1/16. So you also can write the answer in decimal. Okay, so next, actually we can simply copy this, and then later I'm going to change the value of r. Okay, let's change all these values. Okay guys, so this is going to be 1, 1, 4 minus 1, you get 3, 4, C2, the power here is 2, 4 minus 2 is also 2, 4 C3, the power here is 3, 4 minus 3 is equals to 1, and then 4 C4, power 4, and then 4 minus 4 is 0. Okay, and very easily we can calculate the values for all these four what they call calculations using the calculator. So I simply change the value of x with 1. I get 1 over 4, and then when it's 2, the value is 3 over 8, and when we change it to 3, we get 1 over 4, and then when we change the x to 4, we get 1 over 16. Okay, so we start with this one here, 1 over 4. Okay, so when it's 2, it's 3 over 8, and then again we get 1 over 4, and then it's 1 over 16. Okay, done. Okay, let's move to the second question. A fair dice is tossed 3 times. Construct a table and draw a probability distribution graph of getting a number greater than x. Okay, so x is actually number of times getting a number greater than 3. So therefore, the value of x, okay, can be represented using a set like this: 0, 1, 2, and 3. Okay, let's come up with a table for the probability distribution. Okay, let's complete the table, and before that we have to find the value of p. Okay, so those numbers which are greater than 3 is actually 4, 5, and 6. So for fair dice, we have 6 numbers: 1, 2, 3, 4, 5, 6. So out of these 6 numbers, 3 numbers greater than 3. So the probability of getting a number greater than 3 is actually 1 over 2. And then Q is 1 minus 1 over 2, which is also 1 over 2. Okay, in the first column, I'm going to write x equals to r, and then in the second column, I'm going to write the probability. Okay, so x can take these 4 values, which is 0, 1, 2, and 3. Okay, next, let's calculate the probability. 3c 0, 1 over 2 power of 0 multiply with 1 over 2 power of 3. Okay, and then 3c1, 1 over 2 power of 1, 1 over 2 power of 2, 3c2, 1 over 2 power of 2, 1 over 2 power of 1, and then 3c3, 1 over 2 power of 3, and then 1 over 2, 3 minus 3 is actually 0. Okay, and I'm going to use the calculator to find the values. Okay, let's key in 3cx multiply with 1 over 2 power of x multiply with again 1 over 2 power of 3 minus x, and calc x equals to 0, and the value is 1 over 8. Okay, next I'm going to change the x to 1, 1, you get 3 over 8, and then when x is equals to 2, again we get 3 over 8, and the last one when x is equals to 3, and the value is 1/8. Okay, so we are done with the table. Okay, now let's draw a probability distribution graph based on the values that we already calculated in this table. So in this graph, on the vertical axis, we're going to label the probability. So I'm going to label 1/8, 1/4, and 3/8. And in the horizontal axis, I'm going to put 0, 1, 2, and 3. Okay, so when x is equals to 0, so we get 1/8. When x is equals to 1, we get 3/8. And then when x is equals to 2, once again the value is 3/8. And the last one, when x is equals to 3, the value of probability is 1/8. Okay, and let's draw a vertical line to complete the graph. Okay, done. Okay, let's move to the next question. The probability that a pupil continues studies after Form 5 is 0.85. A sample of 8 Form 5 people is chosen at random. Find the probability that all these pupils continue their studies after Form 5. So in this case, the value of n is equals to 8, and the probability of success is 0.85, and the value of q is 1 minus 0.85, which is 0.15. Okay, and let's start with section A. All these people continue their studies after Form 5. So we're going to find Px equals to 8. So 8C8 multiply with 0.85 to power 8, 0.15, 8 minus 8 is actually 0. And let's key in these values into the calculator. 8cx multiply with 0.85 to power x multiply with 0.15 power of 8 minus x. Calc, and then the value of x is equals to 8. Okay, and we have to round out the value that we get from the calculator correct to 4 decimal places. So okay, so the value is going to be 0.2725. 0.2725. Okay, let's move to the second part. Less than 3 pupils continue their studies after Form 5. Less than 3. Less than 3 means Px less than 3. Okay, so less than 3 includes 0, 1, and 2. Okay, so Px equals to 0 plus with Px equals to 1 plus with px equals to 2. And let's calculate the values of each of this. AC0, 0.85 to the power of 0, 0.15 to the power of 8 minus 0, which is 8, plus with 8C1, 0.85 to the power of 1, 0.15 to the power of 7, plus with 8C2, 0.85 to the power of 2, 0.15 to the power of 6. Okay, so when x is equals to 0, we get 2.563. 2.563 times 10 to the power of negative 7, plus with, when x is equals to 1, okay, the answer is 1.162. 1.162 times 10 to the power of negative 5, plus with, when x is equals to 2, the answer is 2.304. 2.304 times with 10 to the power of negative 4. Okay, let's sum up all these three values. 2.563 10 to the power of negative 7 plus with 1.162 10 to the power of negative 5 plus with 2.3, okay, 2.304 10 to the power of negative 4. Okay, and the final answer is 2.423 times 10 to the power of negative 3. Question number 4. A durian is randomly chosen from a few baskets. The probability that a durian chosen at random is rotten is 0.1. Find the expected value and the standard deviation of the number of rotten durians in the sample of 50 durians. So the value of p here is 0.1 and the value of n is 50. The mean, which is mu, can be calculated by taking n and multiply with the value of p. So 50 times with 0.1, the answer is 5. Okay, next, standard deviation. Standard deviation, which is given by sigma, can be calculated using square root of npq. Okay, so since we already have the value of p, we can calculate q. Q is basically 1 minus p. So in this case, is 0.9. So np is actually equals to 5. So I straight away substitute np with 5 and q is 0.9. Okay, that's square root 5 times with 0.9. Okay, and if you leave the answer in set form, it's going to be 3 square root of 2 over 2, and you also can give the answer in decimal, which is 2.121. 2.121. Okay, let's move to question number 5. The binomial random variable x, okay, has a mean of 5 and a variance of 4. A, find the values of n and p. So based on the information, okay, we can form two equations. Okay, before that, let me remind you, mean, which is mu, is actually equals to np. So this is the first formula. And then variance, which is sigma square, is actually equals to npq. Okay, so using the information that already given in the question, with combining the formulas, we can form two equations. So the first one is np is equals to 5, equation number 1, and then npq is equals to 4. So this is the second equation. Okay, so you can see clearly that np is equals to 5. So I can substitute this np with 5. So 5 times with q is equals to 4. So therefore the value of q is actually 4 over 5. So once you get the value of q, then you can find the value of p. P is 1 minus q. So 1 minus 4 over 5. The value of p is 1 over 5 or 0.2. Next, we can calculate the value of n by substituting the value of p into the first equation. So the value of n is 25. Okay, so we are done with part A. For part B, then find px equals to 3. So the probability when x is equals to 3 is equals to, okay, n is 25, right? So 25 C3 0.2, or you can also write 1 over 5. So 1 over 5 to power of 3, 4 over 5 power of 22. Shift divide, we get c, and then 3 times with 1 over 5 power of 3 multiply with 4 over 5 power of 22. Okay, done. The final answer is 0.1358. 0.1358. Okay. Okay, x is a discrete random variables, so that x is given by b 10 comma p. So basically 10 is equals to the value of n, and p is the probability of success. Okay, we don't know what is the value, but it's less than 0.5, and the variance is 12 over 5. Find section A the value of p and the mean of x. Okay, so we know that mu is equals to np, and then variance is equals to npq. Okay, so we know that the value of n is 10, right? So variance is 12 over 5 equals to n, which is 10. Okay, we don't know what is the value of p, but we know that q is equals to 1 minus p. So I'm going to replace the q with 1 minus p. Okay, so we managed to come up with a quadratic equation. Okay, so it's 12, okay, 50p minus 50p square. Okay, let's rewrite this in general form. 50p square minus 50p plus with 12 equals to 0. Okay, let's solve this quadratic equation. The value of a is 50, the value of b is negative 50, and the value of c is 12. Okay, so we get two values, two values. Okay, so p minus 2 over 5 and p, okay, minus 3 over 5 equals to 0. Okay, but in exam you cannot write like this, because when you expand p with p, right, meaning when you multiply p with p, you only get p square, okay, not 50p square. So therefore you have to, okay, rewrite the information like this. Is 5p minus 2, 5p minus 3. Okay, the denominator you transfer to the in front of p. Okay, so 5p times 5p, okay, you only get 25p square. Okay, so I'm going to put a 2 here so that you'll get an equation which is equivalent to the previous one. Okay, otherwise you can divide this whole equation with 2. So you'll get 25p square minus 25p plus 6 equals to 0. Then you don't need to put this 2 in front of the brackets. Okay, and finally you can write p is equals to 2 over 5 or 3 over 5. But if you go through the information that given in the question once again, the value of p is less than 0.5. So therefore we have to reject the second value, which is 3 over 5. So the value of p is 2 over 5 or 0.4. Okay, and we can find the value of mean. Okay, mean is equals to np, n is equals to 10, so 10 times with 0.4, the mean is equals to 4. And for section B, px equals to 4, 10c4 times with 0.4 to power 4, 0.6 to power of 6. C4 multiply with 0.4 to power 4 multiply with 0.6 to power 6. And the final answer is 0.2508. Okay. Question number 7. 20 pieces of fair coins are tossed simultaneously. X is a discrete random variable representing the number of tails obtained. Calculate the mean and the variance of X. So first of all, let's extract the information. The value of N is 20. The value of P is basically 1 over 2. The value of Q, 1 minus P, is also 1 over 2. So mean mu equals to NP. 20 times with 1 over 2, mean is equals to 10. And for variance, sigma square is equals to NPQ. So NP is equals to 10. So we just take 1 over 2 and multiply with 10. And the variance is equals to 5. Question number 8. In a survey, it is found that 1 out of 5 brand A calculators have a lifespan of more than 8 years. A sample consisting of n brand A calculators is chosen at random. If the probability of all the calculator lasted more than 8 years is 0.0016, find the value of n. Okay. So the probability of success in this case is basically 1 over 5. Therefore, the value of Q is equals to 4 over 5. Okay. So for section A, Px equals to n is equals to 0.0016. So therefore, NCN multiply with 1 over 5 to power n multiply with 4 over 5 to power of 0, n minus n is equals to 0, equals to 0.0016. Okay, and we know that NCN is equals to 1. 4 over 5 to power of 0 is also equals to 1. So this is 1, this is also equals to 1. So finally, we will just get 1 over 5 to power n is equals to 0.0016. So we introduce log base 10. Log base 10, 1 over 5, okay, to power n. So I use power rule and bring down the n in front of the log, and it's equals to log base 10 0.0016. So log base 10 0.0016 divided by log base 10 1 over 5 is equals to 4. So the value of n is equals to 4. So in case you get decimal, you have to round off to what they call a positive integer. Okay, for section B, the probability that more than one calculator lasted more than 8 years. More than one calculator lasted more than 8 years. So we have to calculate Px greater than 1. Okay. So if you write Px greater than 1, then you have to calculate what is px equals to 2, px equals to 3, and px equals to 4. Okay, so rather than you finding these three values and you sum of them, we can alternatively minus px equals to 0. Okay, basically at first it become 1 minus px less than equals to 1. So px equals to 0 and px equals to 1, you have to minus from 1. Okay, so 1 minus 4c0, 1 over 5 to power of 0, 4 over 5 to power of 4, minus 4c1, 1 over 5 to power 1, 4 over 5 to power of 3. For c0, okay, and let me use x, multiply with, okay, 0.2 power x. I replace 1 over 5 with 0.2 times with 0.8 power of 4 minus x. Okay, calc. Okay, when x is equals to 0, the value is 0.4096. So 1 minus 0.4096 minus, and the value of x when it's equals to 1, we get again 0.4096. So 1 minus, okay, 0.4096 minus 0.4096 is equals to 0.1808. Okay, let's move to the last question. A test consists of 16 multiple choice questions, and each question has 4 choices, one which is correct. A pupil guesses the answer for every question. A. Estimate the number of questions guessed wrongly. Okay. The probability of guessing a correct answer is actually 1 over 4. Okay. And the probability of guessing wrongly for each question is actually 3 over 4. And we have 16 questions. So we can guess 16 times. Okay. Okay, number of questions, okay, guess wrongly. So you can take 16 times with 3 over 4, or okay, you can find the number of questions guessed correctly, okay, by calculating the mean. So mu is equals to NP. Okay. If the probability of success is guessing the wrong question, then P will become 3 over 4. Okay, but here I'm going to stick to the probability of success is actually guessing a right option, or the correct option. So 16 times with 1 over 4 is equals to 4. So number of questions guessed correctly, and this is 4 correctly. Number of questions guessed wrongly is equals to 16 minus 4, which is equals to 12. Okay. Next, for section B, find the probability that a pupil guesses wrongly in all the questions. Okay. So since they are talking about guessing, okay, the question wrongly, so we switch the p. P we change to 3 over 4, and q equals to 1 over 4. Okay, and in fact we also can do that for section E. If we did that, so what happened? Okay, alternative method. We can straight away take 16 and times with 3 over 4, which is also equals to 12. Okay, so for part 1, px equals to 16, 16c 16, 3 over 4 to power of 16, 1 over 4 to power of 0. 16 c6x multiply with 0.75 to power x multiply with 0.25 power of 16 minus x. Calc, and the value of x is 16. So the probability is 0.0100. And the second part, passes, find the probability that the pupil passes the test if 60% is the passing mark. Okay, if 16% is the passing mark, okay, we have to find out how many questions that you should get correct. Okay, so number of correct answers equals to 16 times with 60%. So 16 times with 60 divided by 100 is 9.6. 9.6. Okay, so the number of correct answers, okay, must be at least 10. At least 10. Okay, but when you get 10 questions which is answered correctly, the marks will be higher than 60. Then you will pass the test. So the value of R is going to be 10. Okay, so Px equals to 10, 16 C10. Okay guys, you have to be very careful here. Okay, since we are talking about getting the answers correctly, so the probability of success is not 3 over 4, it's 1 over 4. C10 multiply with 0.25 to power 10 multiply with 0.75 to power 6. Okay, the final answer is 1.359. 1.359 times 10 to the power negative